We're going to be covering topics under the Standard 5.2 in 7th grade, and also under the topics under the Study Island lesson, probability. So today's lesson is mainly about the fact that probability is the number of occurrences over the number of possible outcomes, and so that's going to be a fraction, so you are going to have to brush up on your ability to reduce fractions. And as we're going through the lesson, just make sure that you're taking notes so that you have those to refer back to when you are trying these problems on your own. And you can even, if I go too fast while you're taking those notes, just go ahead and pause the video, rewind, and get caught back up. And you can even pause at the beginning of a question, work that question out, and then watch the video to see what you did right and where you still need to improve. And so you can kind of get a gauge of what to study that way also. I'm so glad that you're here, and let's go ahead and take some notes.
First, let's write down what the definition of probability is. It's a way to measure the chance that an event will occur. And the formula that we use is the number of ways it can happen over the number of possible outcomes. And we can use a fraction, a percent, or a decimal to show probability. However, most of our answers today are going to be in fraction form. There are two types of probability. The first is theoretical probability, and that's the number of favorable outcomes over the total number of possible outcomes, which is pretty much the definition we copied down on the last slide. However, experimental probability is when you actually conduct an experiment and record the data, detailing the number of times an event occurred. So you would then look at your chart or your data and your top of your number would be the number of event occurrences, and the bottom of the fraction would be the total number of times you did the experiment or trials. Then you can also be asked to find the probability of complementary events. So the chance that you will roll a 6, the complementary event would be the chance that you roll a dice and do not get a 6. So it usually refers to the probability that an event doesn't occur, and you could calculate it by subtracting 1 minus the probability it does occur. And then finally, we can also be asked to calculate independent probability, which is when you have two or more events occur and they have no effect on each other. So for example, you flip a coin twice. The first flip doesn't have any effect on what you get for the second flip. And so if you're looking at that, you would take the probability of the first event, multiply it times the probability of the second event to get your final answer. So now all of those notes we've copied down, let's use them in some problems. So this first problem says a children's game involves tossing a beanbag into a lettered board. The board is divided into 6 sections of equal size, and the sections are labeled A through F. If a beanbag is randomly tossed into the board, what is the probability that it will land on D or E? So there are 2 spots that are either D or E out of 6 total spots. So 2 over 6 is going to be my probability, but I need to reduce that fraction to 1 over 3. Which is going to make D my final answer. In Mrs. Henway's class, there are 8 students with brown eyes, 6 students with green eyes, 8 students with hazel eyes, and 3 students with blue eyes. If a student is chosen at random, what is the probability that the student does not have blue eyes? So that means you're going to have the number of not blue over the total students. So then ones that don't have blue are your 8 brown, your 6 green, and your 8 hazel. So I'm going to have to add 6 plus 8 plus 8, which is equal to 22. Then in the bottom, I'm going to have to add up all 4 groups to get the total number of students. So that's going to be 25. 22 over 25 can't be reduced, so that's going to make my final answer C. This next question says, Julio is trying to guess Amanda's birthday. He knows it's in January, so what is the probability that her birthday is not the 30th? So I'm going to be looking for how many days are not the 30th over the total number of days in January. So January has 31 days. So it's going to have a total of 31 days. 30 of those are not the 30th. You have 1 through 29 and the 31st. So 30 over 31 can't be reduced, so D is going to be my final answer. This next problem, they give us a diagram to help us see all the possible outcomes. And it says, at the chocolate stop, they make milk chocolate, white chocolate, and dark chocolate bars. They also make them with or without nuts. If Frank randomly chooses one type of chocolate bar, what is the probability he will get either be white chocolate or have nuts? So here are the 6 possible outcomes or type of candy bars. So there is, if it's either white or chocolate, there's going to be, he could get 2 of these with white or have nuts. So if we add in could have nuts, that gives us 2 more possibilities. So there are 4 candy bars that are either have nuts or are white chocolate out of 6 total candy bars. So my probability is 4 over 6. However, I can reduce that by 2. And my probability is now 2/3 fully reduced, which is choice D. So here, its standard deck of 52 cards has 13 suit cards. So you have your diamonds, you have your hearts, you have your clubs, and you have your spades. And there's 13 cards in each one of those. Each 13 card suit contains the numbers 2 through 10 and a jack, queen, king, and an ace. The jack, queen, and king are called face cards. So that just gives you, in case you're not familiar with what a standard deck looks like, it just gives you a reference to go back to. So Roger drew one card from a standard deck of 52 cards. What is the probability that the card Roger drew is not a club? So in each one of these suits, there's 13 cards, it tells us. So not a club can mean it could be diamonds, spades, or hearts. So there's 3 other suits. So 13 plus 13 plus 13 is 39. So there's 39 cards that are not clubs out of 52 total cards. And then 39 over 52 can be reduced by 13, and that's 3/4. So 3 out of 4 cards is not a club, and that's going to make B my final answer. The next question includes a Venn diagram, and it says a concession stand sells entrees, desserts, and drinks. They put all the receipts for the last hour in a bowl for a drawing. The following Venn diagram shows what types of items were on the receipts in the bowl. If one receipt is chosen at random, what is the probability that the winning receipt has either a drink or a dessert on it? So here is my dessert, and here is my drink. And when they say either drink or dessert, they're looking for ones that are just drinks, just desserts, or you could have a drink and a dessert. That's what they mean by either drink or a dessert. So if I add up 6 plus 3 plus 4, that's going to give me 13. And then to get the total number of receipts, I have to add up all 7 of these numbers. So 11 plus 20 plus 5 plus 2 plus 6 plus 3 plus 4, that's going to equal 51. So 13 out of 51 is going to be my final answer. The next question says, students at Smith Middle School submitted their votes to the school's snake mascot. The results from one of the ballot boxes are shown in the table. If 2 ballots are chosen randomly, one at a time from the ballot box without replacing, so that means you pull one out, leave it on the table, you pull another one out. The first one, what is the probability that both ballots are votes for SS Sammy? So first I'm going to look at how many total votes there are. So if I add these all up, there's 40 votes in the box. And when I first go to pick one, there's going to be 4 in there for Sammy. So there's 4 chances of picking a Sammy out of 40 ballots. However, once I take one of those ballots out, if it's Sammy, then I only have 3 left that have Sammy in there and 39 total. So those are the probabilities for each drawing. And these are independent events, so I'm going to have to multiply those to get my final answer. So when you multiply fractions, you multiply the tops with tops and the bottoms with bottoms. And you can actually reduce these fractions before you multiply them, which I recommend that you do so that you are working with smaller numbers. So 4 over 40 reduces to 1 over 10, and 3 over 39 reduces to 1 over 13. 1 times 1 is 1, 10 times 13 is 130. So there's a 1 out of 130 chance to pick Sammy twice. The next is looking at a bar graph, and it shows the results of a survey given to a group of 40 college students. One student is chosen at random. What is the probability that the student studies 3 or 4 days per week? So 3 or 4 days per week is going to be these 2 bars. So this bar is a total of 6, and this bar is a total of 7 students. So 6 plus 7 is 13. So there's 13 students that study 3 or 4 days out of the total 40. And I can't reduce that at all, so that's going to make my final answer A. My next question says, Jillian numbered 10 counters from 1 through 20 and placed them in a cloth bag. She then performed an experiment where she drew one counter, recorded its number, and then replaced it. Jillian did this 25 times. The results of Jillian's experiment are shown in the table below. What is the experimental probability of drawing a number 5 counter followed by a number 8 counter if the first counter is replaced? So experimental probability means that we have to use this table. So the first thing that happens is drawing a 5 counter. So she drives a 5 counter twice. So we're going to have 2 over the total 25 times that she does the experiment. And then then that counter is put back in. That's what it means by replaced. And we're looking at the 8 counter. So the 8 counter was also drawn twice out of the 25 trials. So because it was replaced, we don't have to worry about changing the number of trials to 24. And so this is an independent event. They don't affect each other. So I'm going to multiply them. 2 times 2 is 4. And 25 times 25 is 625. So the probability of picking those is 4 out of 625. Choice B. Next question says, Kathleen conducted an experiment in which she drew a marble from a bag one time and replaced the marble after each draw. The results of her experiment are shown in the table. According to the results from Kathleen's experiment, what is the probability that she would draw a red marble and then draw a purple marble if the first marble is replaced before drawing the second marble? So first I'm going to look at the red marble. The red marble was drawn 8 times. Out of how many? Well, I'm going to have to tally that up. And when I tally that up, I get 30 total draws. So it's going to be 8 out of 30. The second marble was the purple marble. So the purple marble was drawn 2 times out of the 30. And once again, these are independent events, so I'm going to have to multiply them. And before I do that, I'm going to reduce these fractions so that they're easier to work with. So now I'm going to go ahead and multiply those. 4 times 1 is 4, and 15 times 15 is 225. And so that's going to, I can't reduce that, so my final answer is going to be B, 4 over 225. This last problem is one of the few where the probability is expressed as a percent. So Kara entered her name into a drawing where the chance of winning a prize is 1 in 17 entries. What is the probability that Kara did not win the prize? So she has a 1 over 17 chance of winning. So that means if I subtract that from 1, she has a 16 out of 17 chance of not winning. So to find that as a percent, I'm going to have to take 17 divided by 16. And when you work out that division, you end up getting 94.1%, which is choice D. Thank you for joining us today, and I hope you learned something new.